We've got quite a difficult type of question for the third video today, but I quite like it because if you understand your forces really well, it all fits together really nicely. So we've got two objects here. I've got a little car and I've got a mass hanger, and they're attached together by a string. If I had a hold of this mass hanger and then I let go, it would fall down and the car would also move. So when you have two objects attached together like this, certain things about them are the same. They're going to have the same acceleration because they're moving together. And also, tension is transmitted along a cord. The tension is the same everywhere. So the tension that is pulling upwards on the mass there is going to be the same size as the tension that's pulling to the right on the car there. But if we draw force diagrams for the two objects, they look very different. Here's the free body diagram for the car. Weight of the car down, normal contact force from the track upwards, tension in the string. We know it's not accelerating upwards or downwards, so these two must cancel out, and the resultant force is therefore equal to the tension. But for the mass hanger, the free body diagram looks like this. There's the weight of the mass hanger and there's the tension. We know the mass hanger is accelerating downwards, so we know the resultant force must be downwards and this weight must be bigger than the tension. And so the resultant force for the mass hanger is that. But in both cases, remember, the acceleration is the same. So acceleration is resultant force over mass. That's the mass of the car. And in this case, the same acceleration is resultant force over mass. That's the mass of the hanger. Okay, but these two objects are attached together, so can't I consider them to be one object? Can't I treat them as one object? I can, but then my diagrams are going to again be different. When you draw the forces acting on an object, you only draw the external forces. What do we mean by that? Well, if this was me, I'd have a weight force downwards exerted on me by the earth. I'd have a normal contact force upwards exerted on me by my seat, but I wouldn't put in the normal contact force that my head exerts down on my neck, because my neck exerts a normal contact force upwards on my head that's the same size and cancels it out. So there are all sorts of forces going on inside my body, a tension force of my arm pulling down on my shoulder, but that's cancelled out by the tension force of my shoulder pulling upwards on my arm. So all the internal forces cancel out. And that means that the tension force of the string pulling on the car is being cancelled out all the way along here and then down, and the tension force that's being pulled upwards on the mass hanger is being cancelled out by the tension in the other direction. So basically the tension forces, they're internal, so they cancel out. They don't appear on the diagram if we're drawing the two objects as one object. Okay, but what about everything else? Well, we had a weight force down balanced out by a normal contact force upwards, so I'm not going to draw those on here either. But what doesn't get cancelled out is the weight force of the mass hanger. And so actually the resultant force on the system as a whole is just the weight force of the mass hanger. But the acceleration is the same whether we're treating them separately or together, and so we can also write acceleration equals resultant force on the whole system divided by the mass of the whole system. Now you can, with a bit of work, prove that these two ways of treating the situation are in agreement. They do give you the same answer. And so if you are up for a challenge, have a go at this question. Okay, so we notice that the trolley, they're calling it, has a mass of capital M. And let's say that the mass of the mass hanger is little m then. And so our previous result was that if you treat the whole system as a whole, the acceleration is the weight of the hanger over the total mass. So that's acceleration is the weight of the hanger over the total mass. And you've probably spotted the answer by this time, but to see it through, the mass here is the weight over g. And so D is the right answer there.